This is our second lecture. Actually, this is our second class, first lecture. So we have different codes in there. One is the lecture number. I have a bunch of lectures, and then we have classes, and then for the students which are at home, we have also tape numbers. So it's a pretty complicated system. Now, in the last lecture, I gave you an overview of the course, and then I started to give you an introduction of telecommunication networks, really. That lecture was called Overview of Telecommunication Networks, and it was our lecture number 1. Okay. Before that, I had the overview of the course. The overview of the course is going to go to the web later on, sometimes next week. These parts are going to be taped. The copy of the tape are available in the library if you want to see that. And for the distance learning students, these tapes goes to their home. Okay. Now, also in the last class, we had this problem that a group of you thought that the class starts at 4 o'clock because of that registration flaw. So I will go quickly over what we said last week, and then I start my lecture today, which is continuation of lecture 1. Originally, I had prepared this course for like 3 hours presentations. Now I'm cutting that in 1.5 parts, and I want to fit it also into the tapes. So I may change my speed a little bit or whatever, because we don't want to have too many pieces in the tapes when they go out. But we will try to see what will happen. Okay. Now, as of like overview of the telecommunication networks is concerned, we started by definition of the telecommunication network, which is basically a railroad system, if you want to call road systems. That's a traffic backbone. And then the traffic is the information that you send over this highway, if you want to call it information highway. And then your car is your terminal. Okay, so you have a bunch of cars. Well, maybe car is not terminal, but anyways, the terminal is something that takes your information, transfer it to something that can go over the highway system, if you want to call it. But then I talked about the evolution of these terminals from the time that we had a simple Morse code driver up to the time that now almost everything is a terminal. And this is a different environment. Now, then in order to connect this variety of terminals, which are running different applications, we have to define different type of networks. And later on today, we try to classify these networks. And so that the study is going to be a little bit easier. And then basically, we said except that terminal, which is very important and connects us to the network, backbone of the network basically consists of some switches or routers, which are connecting point-to-point links, if you want to call it. Okay. And there are a variety of links and variety of switches. And today, the companies which are working in the backbone, mostly on optical backbones, and the companies which are working on the switches, they're working on integrated switches, which are faster and faster in terms of exchanging the information and interfacing with different standards. Because these point-to-point links, some of them are internet links, some of them are voice links, and they have different data rates. So the switch which comes in between wants to get from one and add it to the other one. So that's the state of the art. Make it faster and faster. Okay. That was what about that one. And then I had some comments about the IT industry, that it is true that we had in the last year a major crash in the industry, in particular telecommunication industry, and the stock of these industries has gone way down compared with the year before. However, still this is the largest industry in the world. Okay, and still they have a lot of jobs to support in the future. But immediately right now it doesn't look as good. Then I started to go over the history and how history evolved. And while I was going over the history, really my purpose was to tell you that there were a series of problems that they existed from day one up to now. Okay? That was one of the things. What were those problems or issues? One was like voice versus data from day one. One was analog versus digital from day one. One was wired versus wireless, almost from day one. One was short haul versus long haul, like going over the ocean or staying in a continent. Okay, these issues still are the issues for the telecommunication industry, no doubt about it. Okay, and that was like summary of what I told you in the last lecture, which with more detail and also overview of the course. I think another issue that I discussed in the last lecture was this issue that telecommunication industry today has three major sectors which are providing three different services. One is like voice network, which is like telephone, regular telephone, which has most of the backbone is that, and money is generated in that backbone. Okay. And then we have the wireless industry, which is a method to access to the backbone. But still you pay separately for that because you have different terminal and it's more expensive to connect. Okay. When you go to the backbone, you pay for what? This wire that they have laid down from here to Japan. Huh? When you pay for wireless, you pay for the expensive terminal and you airtime. Okay. That's how you pay. And then, so both of them basically today they are generating, both fixed networks and mobile network today, they generate this income that you see in here through voice application. Data is starting to pick up in the mobile. Then data in the internet actually has its own territory, which is like another part of this big segment. So we have data-oriented internet, okay, and then voice-oriented wired and wireless, if you want to call. These are three money generating today. Future people are thinking about wireless internet would be like a new addendum to this picture. So there is a lot of like investment in that field. And new companies mostly are in that field, like data for. And then there is another field actually which is growing in this whole, in fact, area that's related to switches, for faster switches, and then the backbones, which I mentioned earlier. And then wireless voice industry also, they are trying to go for more efficient ways of using the bandwidth that they have. See, in the wireless networks, you have a fixed bandwidth, like 25 megahertz at the beginning you had for one direction communication. And with that 25 megahertz, you have to support everybody, okay, all around the place. Everybody is millions of people, okay. So it's very important to have more complicated systems to use that bandwidth more efficiently, because that bandwidth is sold by FCC to people, okay, to the companies. And these companies, if they have more efficient way of using that bandwidth, they have more customers, they generate more income. Okay? So that's another area. They call it 4G. Next generation. Always, I call it next G. No matter where you are for the wireless networks, always they are talking about next G. And next G is the one, the next generation, which uses this available bandwidth more efficiently than existing bandwidth. Okay? Today, deployment of the 3G system is on. People are thinking about 4G. And the difference is in capacity only. Okay? So that's another industry for itself. Okay? And then there is another industry, again in the wireless. Most of the research these days are around wireless. Development, research, everything. And that one is for a speed of wireless access, which is wireless internet that I told you. For wireless internet, the challenge is to go to higher data rates. Okay? So again, a lot of startups around that. For the 4G, they don't have as many startups. They have just big companies like Nokia, Ericsson, Motorola, and Docomo, Japanese companies. They are working in those fields for 4G. Okay? But startup companies in more innovative things like wireless internet access. That's just a good picture of everything at this stage for this class, which is the first class in telecommunication. Now, then I talked about new paradigms that, the application which used to be for telecommunication industry, the major application in terms of generating income was only voice. Okay? But now it's augmented with web browsing and short messaging. Okay? And then the industries at the old time, they were separate industries. You had this like computer communication industry, which was separate, and it was very small. And then you had telecom industry, which was voice only, almost, dominantly. Only, I don't mean in terms of technology, in terms of generating income. And then we had consumer products that they were not even networked many times. So Sony was in consumer products, which was designing like radio, TV, etc. And then AT&T was like telecom, and like, let's say, Codex was information technology, for example. But today, all of these guys are merging together because consumer products are getting more networked in one hand, and then information technology is generating incomes which are comparable now with the voice industry, so calls for merger. Okay. And meanwhile, multimedia is coming in. People are interested in applications which have voice and data and video as well. Okay. More or less, that was it. This is the slide that I finished last lecture. At this point, I stopped in the last lecture. Now I go to a new gear, really. The gear up to now was to giving you a very broad overview of the networks. Now what I want to do is get slightly more specific. Okay. And what I would like to do first is to categorize, to differentiate, because this is a very, very big and multidisciplinary environment. In order to differentiate, the first thing which is just the information source itself. Okay. Information source either is analog or is digital. But basically what we talk about current and the future is digital. And there are three sources of information. One is voice, one is data, and one is video. Okay? Voice, text, and video. So often, for those of you who have not been in this area, the first question which comes to your mind, you say all of these things are digital, or zeros and ones. How come I don't use all of them in the same network? Okay, it comes very, very easily into mind. The reason that they are not using the same network is that the requirement for the packets of voice and packets of data and packets of video are different. As a result, the network that you create, either the point-to-point connection or those switches that you have in there are different. They evolved differently, it's better to say. But today, people try to merge them. But when they want to merge them, they have difficulties, again, because of this difference in the features. What are those differences in the features? For the voice, the way that the application for voice that we are used to, and the one which was generating the income was what? Telephone calls. So because I can have voice messaging, for example. That's not telephone call. But the one which was generating one of those 3/3 of the income of the industry was telephone conversation, dial-up telephone. Okay. So what was characteristics of dial-up telephone? Let's say I have a digital voice and then I have a network for that. So the voice comes to the packets and I want to send it over. What are the characteristics? Number one, when you're talking about voice networks or voice packets, they are periodic. I mean, pseudo-periodic. Because telephone conversation, they are used for real-time telephone conversation. And assumption is that it's 50% in each direction. Now, it's real-time, it's symmetric, and it has high volume. Because when you talk like 5 minutes, you generate something like 5 megabyte of information, something around that. Okay? So there's a huge volume of information in each session that you have for communication. Okay? Then these packets that you have, since they are real-time, they are sensitive to delay and jitter of the delay. Means that when I generate packets in here and you want to listen to my speech in Japan, these packets have to come with certain amount of distance from one another. Okay? And at the same time, they should have the whole packets. On the average, they have to have certain amount of delay. For example, if I talk from here and on the average you're sitting in Japan and you have like 100 milliseconds, more than 100 milliseconds delay, the voice is awkward, too much delay for the jitter or in between. Okay. Now, so what they do is that when they design a network, they don't put acknowledgement, for example, in that because it takes too much time. And then when the packets are arriving and they want to put them together, if a packet arrives more than 100 millisecond delay, they drop the packet. Okay? As a result, see my terminals at two ends, the protocol that I use for communication, switches that I have in between are different. They have different requirements. Okay? Then, another thing which is important for the voice is that voice is a big volume. If I drop some packets in between, nobody cares. Okay? So I'm insensitive to the packet loss. I can tolerate for that. All of these things together, they want. In addition to that, we have got used to this connection-based voice. Means that we make a dial-up, and they give us a line, and the quality of that line remains the same, and then we hang up. That quality remaining the same is only a tradition, which came from the early days of Bell. People are changing their habits these days. They go and talk on the wall, on internet. And when it's not good, they don't talk, but they don't pay. Huh? But I'm talking about the one which generates money, which is for what? For the telephone companies. It's connection-based. And people are used to what? Quality of service. And they pay for that quality of service. Okay? So if I have two choices, for example, I mean, I had one of my students actually, he was working on voice over IP. Then in part of his project, he decided to get married and go with his wife to Macedonia. And he was my research assistant, and we have to talk. Okay, he picked up the terminal, he goes there, and from there, he doesn't want to pay. He calls me through what? Through internet. But I have to wait like 3 seconds to hear his voice. I cannot afford that. I get his number, I call him back. Okay? Because I can afford. So I pay for what? Why did I call back? I paid for quality of service. That's the meaning of quality of service. Basically, this example identifies why people are talking about quality of service. Why now I am not patient? Because I'm too old. Huh? Why he is patient? Because he is new. Huh? You are older, you have more money, you pay. Okay? And you're younger, you have less money, you don't pay. But there is the issue of quality of service. Okay? And the equivalence of quality of service with what? Generating income. That's from the point of view of what? Service provider. So telecom industry, which is used to people to pay them for quality of service, still they have a lot of attention to that. And throughout you will see that. A lot of fights in the industry on the quality of service is because quality of service generates a lot of income. Why? Because people are used to it. Okay? So that's the characteristics of the voice in terms of giving you some ideas, okay, for the introduction to the course. Now, going to data. Data in nature is different from voice. Why? Number one is that data is bursty. It's like a burst. It comes in, I'm sitting in my terminal, I type like 5 words, I send an email to Jinrang, and then I don't do anything for 15 minutes. Okay? And the answer could be that he sends me a big file. So it's asymmetric, okay, and it's bursty in nature, okay. This is up to here, okay. Now, always delay jitter is not that important in data, okay. So when delay in general is not as important in most of the application related to data, pure data. So my example in the old time for that was that I go to these ATM machines and I put my card, and it takes a few seconds to come back. Few seconds, no problem. Even 10 seconds, 15 seconds, no problem. After that, I start to kick the machine. So patience for tolerating the delay in the data is what? Much more. In the voice was like 100 milliseconds. In here, up to several seconds. People have patience on that. Okay, so sensitivity is not there. But on the other hand, in the same application, when I go to the ATM machine and I receive a packet which has an error, that's my banking account, and shows 3 more zeros, I cannot tolerate that. I cannot even tolerate packet loss. So as a result, what they do is that they have to have a more reliable system. More reliable system always has feedback. And that feedback causes what? Delay. But no problem, they accept it. So the protocol that they designed for that, the network that designed for that, will become what? Different from the protocol and network for the voice. Okay. Then the last is like video. For the video often, most of the applications for video are streaming, continuous real-time signal. That's the one which is popular. We watch TV. That's the most popular one. It's asymmetric, and it is, in a sense, similar to voice in the sense that it is sensitive to delay. Again, since it's real-time application, it's sensitive to delay. Okay? Because these frames of the video should come at certain times. Okay? So the only difference that it has with the voice is that it's not symmetric and the bandwidth is much higher because the speed is much higher for transferring the video. Okay? So often people combine voice and video really because as, let's say, call it, some people in 802.11, they call them time-bounded services. And then data is like asynchronous. Okay. Another word that they use for that, for the data, they say asynchronous. Voice and video, they call it isochronous. These are the variety of words that they use. But basic difference between them is what? The issue that network is sensitive to the timing or not sensitive to the timing. And that timing, again, goes with the quality of service. Okay? So if my network has quality of service, it can, number one, provide control over the delay. Number two, control over the throughput. Usually the rate and throughput, they go together in compromise. But anyways, so I have three sources of information: voice, text, and video. And since the characteristics of these three are different, people have developed three different networks for them. The network for the voice is what? The so-called public switch telephone network. It's a voice-oriented, connection-based network. For the data, they have created internet, okay, which is a data-oriented network. For the video, they have created what? Cable system, which is actually, for the time being, is an analog system. Okay. So these are the three major, in fact, sources of information. And in the past, since people were processing this information separately, they have created three different networks for these three applications. But as we go throughout the time, they are merging together. Okay? Why? Because we are going to have voice over internet, and we have video over internet too. So this is where we are right now, at the time that we want to merge all of these guys. So in order to merge that, what should I do? I have to change all my switches, all my backbones, okay? And then the method that I access the network. But we get to that a little bit later. Now, starting with voice-oriented networks, public switch telephone network, and actually evolution of all the networks, I have a very good animation on the web. If you have not seen it, you see it. That's how this network, the whole network, evolved, which is part of the material that I covered in the first lecture, but it's in a different wording. So I recommend that you have a look at that on the website. But anyways, today the voice-oriented public switch telephone network, which we call it PSTN, is consists of circuit switches inside and also digital inside. Digital in the sense that each voice, that telephone conversation, is encoded to 64 kilobits per second. Okay? That's called the speech coding rate, okay? Inside the network. When it comes to your home, it comes through twisted pair wiring, or to your office. Comes through twisted pair wiring and comes in the analog form. So they have an end office in here, which is one of those switches at the end, which turns your digital information either at that point or a little bit before that, some of the switches before that, to analog. And then it comes to your home, you hear that, but analog, in the analog form. Okay? The service which can change this thing is ISDN. ISDN changes that analog voice to digital voice. Okay? But ISDN, so though it had a lot of hope during the 80s, never met the market. Okay? This was one of those examples that I told you. In telecommunication industry, we see examples day in, day out of big hope that they never meet. Okay? One of them was ISDN. Okay, but that's not that they don't meet the technology. No, the technology is easy, it's there, but the market doesn't develop the way that they wanted. And often at the end, when it didn't meet, they say that it didn't meet the window of time. Always there's a window of time in which if you come in, you're in, and if you're not, you're not. But I mean, that's even oversimplifying the fact. Anyways, this telephone network is also augmented. This telephone network, as we talked about it earlier, it started before the 20th century. And then for 100 years, not much of difference. Just, I mean, in terms of service, just they went to automatic dialing from talking with the thing. And they improved the switches. They improved the condition of the lines. And they also improved, they brought multiplexing into picture. Means that you can take many users and put it on one wire, for example. That was the innovations in that sense. But from the application point of view, not much of difference. Then, about like 100 years later, the first innovation was like they brought PBX system. PBX is no change really from that. is a private switch box. Okay? So rather than telephone company owning the switch, they give you a switch to put it in your own company. But if you put that switch in your own company, number one, when you have internal calls, you can avoid what? Avoid paying. And then you can add added feature things. You can add digital services to that. Okay? So you have certain flexibility really in there, but basic application is still the same telephone, the same old telephone. So that was not much of change. And analog telephone. Most of them are analog telephones that you're getting connected. There are some digital PBXs available too. Okay. But another change which happened more recently since 1980 was addition of the cellular or wireless telephone or cellular telephone if you want to call it. Cellular telephone has its own switches and has its own cloud, point-to-point. But it's interfaced with public switch telephone network and works with that. Why they need their own switches? Because the switches that they have in the public switch telephone network do not support mobility. And in wireless application, you have a telephone which is today connected in here, tomorrow is connected in another place. So the switch has to be what? Mobility aware. So the existing switches in here, they don't work. They add mobility aware switches in them. So as a result, cellular telephones, they don't connect to the public switch telephone directly. They connect through an interface network, which has its own switches and point-to-points. And those are mobile switches. Okay? Or mobile-aware switches. Okay? Now, in terms of service, what mobile did, mobile originally was designed for using telephone inside the cars. That's how they started. But as the time passed by, the terminals became smaller and smaller. People could take it and come out of the car. And when they came out of the car, they could take it gradually inside their home. They were not designed for that. And when they got it inside the home, gradually people don't get regular telephones. So they are replacing the regular telephone. And then this industry which evolved around this, also for itself, it was rapid deployment, so it became like a competitor for the what? For the regular telephone. And then you go to Finland, which is now the leading country in the wireless cellular system. Penetration rate is 75%. Means that 75% of the population, 5 million is population of the country, 75% of that, which is 3/4 of that, they have cell phones. Okay? The highest penetration before that, I believe, was for the regular phone, was in the United States, I think, less than 50% for the wired type of thing. Okay? So that's like just to see what is going. So this is shift of paradigm also. So the telephone, regular telephone, is going away. When I go to visit Finland, which I go like a couple of months per year, I never get like a fixed line. I never get a PC either. I take my laptop and I have a cell phone in there. And that's it. But this trend is becoming now popular, and it's changing that perception of telephone that we had like in 1970s. In 1970s, when I was a student, as soon as I came in, I'm in the apartment, I call the AT&T, I get my telephone. That's the first thing that I do. Okay? But I may go now with my telephone to the new place, which is my cell phone. Okay? It's a shift in paradigm, in fact. Okay? But anyways, this is the whole network. Another change that this cell phone brought to the telephone application was that the cell phone, first generation was analog, second generation became digital. And when it became digital, then you can integrate voice and data. So really a cellular phone is ISDN service. So that's the first popular ISDN service. That's the so-called 2G, second generation cellular system. In here, that's CDMA technology. In Europe is GSM. So GSM and CDMA are really the first ISDN services, integrated services. Why it's important to integrate the services? Because it was so awkward. If the voice and data, both of them, in the core network are digital, why shouldn't I combine them? Huh? But it didn't work earlier. But it worked for the cellular system. Okay, so that's another change. So as a result, this terminal that I have in here, which is my voice terminal, and it was designed to just improve the capacity. Do you remember that I wanted to improve the capacity? Originally, GSM or digital cellular, at least in the United States, came to picture to increase the capacity of the analog. Okay? But at the same time, it provides what? Voice and data services. Since it provides voice and data services, this is a new opportunity. Now, what happened in here? In that new opportunity which came there, people started to use short messages. Short messages was not very popular in the CDMA system that we had in here, but in GSM it became suddenly very popular. As of like 2 years ago, as I said maybe in the last lecture, 20% of the income of cellular providers in Finland went to short messaging, which is the first popular wireless data application in the world. As we will see in the other courses later on, wireless data was never meeting the predicted market. But short messaging was the first one which generated so much of income. But anyways, we are coming to the point that short messaging systems, which are used in the terminals, are the first popular data in the form of ISDN, which attracted attention. And now that it's becoming popular, actually it's grabbing the market from the voice. A lot of people in the GSM territories, they don't talk anymore. They send short messages. I told you 200 billion short messages in year 2000 just was exchanged. Why they don't use it? Partially because there's a shift of paradigm. I was used to call people, and now I won't. Because a lot of calls was for what? Short messaging, really. I call to see that if certain person comes to play tennis tonight or not. I don't need to call, and I send a short message. Most of my communications are like that. Okay? So as a result, we see just shift of paradigms. Okay? Paradigm is I was used to telephone call because that was the only thing which was available. Now short messages, I changed my habits. So it's possible that 10 years down the road or 15 years down the road, dialing telephone network is gone. Because I have other means for personal conversation. I don't have urgency. I can use web. Huh? And for like short messages, I can use like short messages. So this is like shift in the application. Okay? And then what industry is dying? Do you remember telecommunication industry in AT&T in 1980s early? The budget was equivalent. Major industry. Now it's changing, completely changing. Because the users are changing their habits. So change of habit of the users is extremely important in shaping the industry. Okay? Now, anyways, that's about like voice-oriented public switch telephone networks. But I told you we have two other networks right now. So this is the traditional one. These PSTN people, since they were here from day one, they know how to lay the wires under the ground. When you want to lay the wire under the ground, you have to come up with an agreement with the city. Huh? If you want to go over the oceans between the countries. So it's a very complicated procedure, but telecommunication portion is not that complex. I put a wire and some repeaters, the same technology. But for somebody who wants to put like a new network together, okay, For those people, the difficulty is not technology. The difficulty is dealing with the towns, get the permissions, lay down the things, and have that system which goes down. I mean, technician goes down and fix the wires and comes in. Okay? That technology is what telecommunication, voice-oriented people from the old time. Okay? And that one has two sectors. One is wiring within the cities. One is wiring between the cities, like wire over the ocean, for example. So I have long haul, and then I have short haul. And the technology and the method for long haul, short haul is so different that when they diversified AT&T, they cut them into two different sectors. So they have these baby bells, which are doing what? Local in the cities. And then they have AT&T, which does the what? Backbone. Okay. What do they do in terms of technology? The same thing. They have the switches and the lines. But that the permission, handling, and operation, which is more difficult. Okay? Okay. So public switch telephone network people, or let's say AT&T in the States, is the one which knows how to lay wires in the buildings, in the oceans, under the ground, everywhere. And then public data networks are coming in. You remember in the last lecture I told you, public data people originally started with what? With modems. So these are the companies. The first is Air Force, and then like banking companies, etc., airline reservation. These guys, they want to develop the technology. They go to AT&T. AT&T designs what? Modems, and gives them. And modems connects their computers from different points. But in between, what is going on? In between, there are lines which they call it leased lines. There are the lines that lease from who? From AT&T, from PSTN. Master of wiring. And the leased lines are very expensive. Like one T1 carrier line goes like something like, for short distances, goes like $10,000 per year. As a result, these guys who are designing modems, later on they allowed other companies to design the modems in 1968. Before that, only AT&T was in it. Now, when they allowed that, now these companies, they were trying to go to higher speed modems just to pay less for the lease lines. So as a result, in like 1983, for example, the first 19.2 modem which came in, guess what was the price? $13,000 by Paradigm was announced in 1984, 1983, something like that. At that time, with $13,000, you could buy a mini computer. Okay? So what is going on? What was the incentive? Why people were paying that much for a modem? Because using a 19.2, rather than 9600, you use one lease line rather than two lease lines. So this is economy which is behind the development of technology. Okay? Anyways, so this public data networks or private data networks, whichever you want to call it, public is like Telegram and things like that. Private is what? Like banking system. Both of them, they are based on the device, modem. It's a part of device, part of interface. And then the backbone is still paying to the telephone network, because they know how to lay the wire. But they came out of monopoly. Now other companies are in. Okay? As soon as fiber came in, things become more simpler. Switches became more complex. Everything is more simple. So now other companies are coming in. MCI comes in to compete with what? AT&T. Okay? The Sprint comes in to now they have their own backbone. Okay? But anyways, these are same business of creating the backbone. Then the data network people originally were using modems. They were using the same thing. How about later on? Later on they came to what? They came to internet, as we saw earlier. When they came to internet, what they were using in internet? How did internet work? Internet had new switches. Switches in the public switch telephone network were what? Circuit switches, which means that they have a router, they have like a routing algorithm in the end office, and the end office, which is next to my telephone, decides which switches I will connect, and then each of those switches, they give me one connection. They connect me from here through these switches all the way to Japan. This is how it was working. But switches in here are packet switches. Packet switches are going to take the packet and decide where to send it. Okay? So the routing is taking place step by step. The advantage of that one is that it's, as I said, for the military application, the advantage was that it's survivable. It's a survivable network. A router, because if you hit one router, data goes through another router. Okay, so it's a survivable network. But on the other hand, it's fitted only for data at that time at least. Why? Because I have to store and forward. When I store and forward, I have to store all these messages and decide where to send them. So it causes delay. When it causes delay, then it's not suitable for what? Real-time application like voice. So they start to develop this internet with different switches. But how about point-to-point? Point-to-point is still switches, they lie in one office. I hire 5 offices, and I rent offices. That's easy. And I put some switches in there. But connection between switches, I have to talk with the cities. I have to know wiring. Who does that wiring for internet? Again, public switch telephone network people. Okay? So they come, this is the AT&T at that time, which provides them with the backbone. They just change the switches. Because they are master of wiring, because the problem in communication is wiring. Okay? Wiring is infrastructure. Still laid down over, like under the major buildings, under the ocean. So here it is. So internet evolves really. The evolution of internet is different from PSTN. Because internet is in a sense what? A virtual network. It uses PSTN wiring. Okay? But its own switches. Okay? But anyways, we call it a different entity. But we have to remember that they are paying their dues to the PSTN, to the growth of PSTN. Then in the data application, as we saw earlier, so we were private data networks, then internet started to grow. And also another thing which grew in earlier than internet actually was local area networks. And as I told you, local area networks were what? Were evolved for what? To connect huge number of terminals which were growing in 70s in the computer-oriented industry, like IBM and Xerox, etc. Okay? This is how local area network came to picture. But later on, local area network got connected to internet. And then they get augmented with wireless LANs. Okay? Another event in there, a data network, was wireless data networks. Wireless data networks is similar to these private data networks. Similar to that. But these are for wireless connections. Okay. Wireless data networks, similar again to cellular networks, they have their own infrastructure. So they have their own routers, which are different from the routers of internet, because these routers in here, they have what? They have to be mobility aware. Okay. So this is how it was. This is 2 evolution. And the 3rd evolution was this hybrid fiber coax, which is the name of the network, which is used for what? For the TV, the cable TV. Okay. Cable part comes to your home. Fiber connects the endpoints together. Okay. That's hybrid fiber cable. Basically, when it comes to your home, is analog. And it had nothing to do with the other 2, in a sense, because this was a broadcast system. Okay? Just broadcast in one way. But as they came to the popularity of internet in 1995 and after, people started to think about how to provide high-speed data to the home. And to provide high-speed data to the home over twisted pair firing, which is the wiring which goes with the telephone to home, they had to design DSL services. Equivalently, people started to develop cable modems to use the cable which takes the TV and provide high-speed access to internet. And today, cable is the most popular. But in order to do that, they have to what? Change the system so they have a feedback channel. Okay? And that's, anyways, today is the most popular in the States. Okay? Now, and we discussed about how like AT&T started to buy these companies and they were not paying attention to them before. So when I look at today's, in fact, around me, I have like 3 networks. One is like PSTN, which is the master of wires and wiring and everything, and they have their circuit switch. That's one way to think about it. Internet, which is a virtual network, which connects all the data networks to one another. And then they have cable TV network. Now, how about the backbone of the cable TV? Who provides that? Again, the telephone company. Because they are the ones who can provide you the cheapest, those fiber connections, the cheapest way. Okay? But the cable, I can get it from like last few miles, distributed myself in the area. And even for that, I may use excavations, which are used by the telephone company. Okay? So they get mixed in a sense. But anyways, I have like internet, a virtual network, the cable TV, a part of that, which is the access to home, certainly they own their own infrastructure, their own wiring. And that's very important. Okay? But inside that is again virtual. It uses the PSTN. Okay? So this is what it is today. Okay? Now, by these companies, AT&T buying internet and cable companies, they are mixing all of them together to make one network for everything, to provide everything over that. And that's the trend which is going on today. Okay. So this is the status of like telecommunication industry. Now, what I want is to get this whole picture and create some sort of like divisions in there, and later on classifications. A variety of ways that you can divide these things together. Why do you want to divide them? Because then issues related to each of these divisions are different. Okay, that's why you want to divide them. The way that I like to divide them is, first I call one group the backbone group, which is like PSTN, internet backbone, cable TV backbone. Okay, this is just a backbone. This is connection between the switches, okay, or routers, or endpoints in the cable TV. That's one backbone. Okay, I call it backbone. Then there is another part, I call it access. Access, really, we have 3 types of access. One is access to the office, one is access to the home, and one is wireless access, which is from everywhere. I can use it home, office, wherever. Okay. But in particular, this access to the home and office are different. We can classify them differently. See, backbone for PSTN, internet, and cable TV are different. Okay. Access to home and office are different too. Okay. And I will see what are the differences in the next step. Now, then there is a third one, I call it distribution. Distribution, again, in the office and the home is different. What is the access? Access is that last mile cable which bring the PSTN to my office or to my home. Okay? It could be a wireless point-to-point also. Okay? But it comes to home, they use different technology. It comes to office, they use different technology. Because often when they go to the office, there is much more bigger customer in there. To home is individualized, so it should be inexpensive. Access to home should be much more inexpensive. Okay? But income which is generated from the home is more than office because number of homes are much more than number of offices. Okay, so that's how it works. Now, then is the issue of, now I come either in home or I go into the office, I have distribution systems. For example, if I get a telephone network, I come to the office, I have this public switch, PBX, not public switch, private box exchange. I have PBX system for distribution of the voice inside there. But inside home, I don't have PBX. So my distribution system is different in home and in office. The same is for the data. Okay? For voice and data, they are different. Okay? For cable, for the video, also it is different. I don't have video in the offices. I have video only in the homes. Okay? And the distribution is also different. So this is three classification. I said there are three types of networks. One is backbone networks, one is like access networks, one is distribution networks. That's what I like to divide them. If you get the standards activities, they are either related to this, this, or this. Okay? But sometimes they overlap. Okay. Now let's go to each of these things and see what they do. First, the backbone facilities. The major backbone facilities which are available are public switch telephone network, internet, and cable TV. As we discussed earlier, public switch telephone network evolved for what? Voice application. I mean real-time, two-way telephone conversation with quality of service. This is how it has evolved, this network. Backbone is circuit switch and supports packet data, supports data in digital cellular and ISDN services. Okay? So it provides the data. It has evolved over voice, but it provides data. Okay? I call this type of network voice-oriented network. I like that division. Okay? It's voice-oriented. Because it has evolved for the voice. And it's for isochronous type of application. I mean, all those differences that I told you earlier. Okay? Well, if I add data, I have added data, but with labor, more labor. Okay? Then I have internet. Internet is what? Evolved for data application. It's a packet switch network, but it supports voice, voice over IP. Okay? But it's a labor that I have added to that. But necessarily doesn't mean that, well, I mean that if it was designed for the data, it's not suitable for voice. No, actually, when they designed these routers and they started to look over voice over IP, they find out that what it's actually cheaper for the voice to go over what? Over the IP. So a major evolution now going on in the telephone network industry is that they want to use voice over IP. Okay? What is the incentive for that? Voice over IP doesn't have as much quality of service, but the cost is much less. So because of that, people are getting what? More interested in that. And a bunch of new companies are evolving in that area in the past 2-3 years. Then, the third backbone facility that we have is cable TV. Cable TV evolved for video application, analog video distribution. It's a multicast system because you can select certain people and give it to them. Okay? Now, and support broadband access, which is data application, which is digital and is two-way. Okay? So these are the three backbones that I have in here. Okay? And their characteristics. If I want to, like, divide them. Now I have a general picture of the entire telecommunication industry. This picture is very important. Because when you want to develop an application, You have to have a big picture to develop it over that. Okay. So what was the second sector of the industry? The first was backbone. The second one was access facilities. Access was what? Something which brings that big cloud to what? To either home or office. These access facilities, as I told you, are different for what? For the offices, and they are different for the homes or small offices. A small office is really a home, like a real estate agency. Okay? It is a home, really. Now, they operate the facilities or the way that telephone company or internet company brings the information to large offices and small offices and home are different. There are two different sectors of the industry. You can divide them from one another. The companies who are in this business are different from companies which are in this business. They're different. Okay. Why they are different? Because in the offices, generally, telephone company brings a T1 carrier, okay, which is like 1.4 megabit per second, or frame relay, which is 2 megabit per second, okay, and delivers to your office, or goes to higher rate hierarchies, which are multiples of this. But the minimum is like 1.5 megabit per second, 1.4 megabit per second, which comes to the large office with one wire or one cable or whatever. Okay. And there are very limited number of offices around. For that connection, they can charge something like what I told you earlier, something like order of $10,000 per year to lease that line to come to that place. But they cannot do that to homes. Homes cannot pay $10,000. So they have different type of technology. But they don't want those data rates either, because they don't have as many number of users. So what will happen is that for voice, video, and data, they have different means to approach the home. For the voice, public switch telephone network, either wired or wireless, provides both voice and the data over voice type of services. Okay. Satellite companies also bring video and data to homes. Cable companies bring video, data, and voice to the homes. And even power line companies are trying to bring low-speed data services to the homes. Okay. But that one is, I put the question mark. It's a little bit questionable. But the major distribution lines which are coming to your home are what? Three of them. One is the distribution, the thing which brings the service to home. One is like public switch telephone network, okay, which brings either voice and data. The other one is the cable company, which brings video, data, voice, all of them these days. Okay? And then satellite companies, the same. They bring video and data. And even voice, but for voice, they are not very keen, because in satellite, you have too much delay. Okay? Now, so that's like access facilities. This is how this telephone network gets, or I mean network, a telecommunication network, accesses either home or office, and the method of access is different. Now, if a public switch telephone network brings the wire to your home, they charge you like what? Something like $30 per month, something like that. And to get more out of it, they try to add services, added value services. Use the same wiring for the data, for DSL, for example. Okay? But the initial charge cannot be more than, cable companies, $30, $40 per month. They charge you. But they try to add more services to extra. But you end up to pay from home like average at least like $200 to $500 per month of telecommunication services, which is distributed between these guys. For your satellite, for your telephone, and for your cable, on the average, I think you pay between $200 to $500 per household, okay, per month, which goes per year like $6,000. Huh? Between $6,000 to $1,000. Which compared with these guys, T1 carriers, which was like $10,000, they are generating more income because homes are much bigger. But the initial cost is smaller. The method of marketing is different. Huh? Now, so that's the distribution. That was the access. The last sector of the industry is what? Distribution. Distribution industry, one is for offices again, one is for homes. Again, distribution industry for the office and home are different because offices, people have a lot of money. Huh? So they want to wire the electrical engineering department. First time they wired this campus, guess how much they paid? That was 1985-6 for local area networks. How much they paid for the wiring of local area networks in WPI? Guess how much they paid? Just the wiring. $5 million, something like that. Just for the wire. Why? Where was that money? Have to excavate all around the place. They have to snake these wires inside the walls, go to every room. The labor is very high. It's not the cost of the wiring. Okay? They wired the electrical engineering department last year. They paid several $100,000 for that. To just go from 10 megabit per second to 100 megabit per second LAN. That's for LAN only. That's what I told you. For the PBX, again, different. Okay? These days, they try to wire at the same time everything. Okay? Because if you bundle the wires, the price doesn't change. It's the cost of installation which is very high. Okay? But anyway, now, you want to do like a network inside, distribution network for your home. Are you going to pay $5 million? Oh my God, no. No. No, you cannot do that. So the requirement for the home is different. So distribution system in the home is a different thing. When I come to the offices, I have local area networks. This is what they have. They have like become popular. And PBX. PBX for voice, LANs for data. When you come to the home, inside the home, I have telephone wirings. Telephone wirings, they charge you 30 per like 30 to 50 these days, huh? For just add one more plug inside the house. And when they build the house, they put these things is much less expensive. Okay? Otherwise, they couldn't afford it. Okay? So, now, however, since I have the telephone wiring inside the home, okay, I try to develop technologies that I use it for data as well. The technology that they have developed to use the data over the home wiring is called HPNA. Okay? So the wiring distribution inside my home has to be inexpensive and existing. So I have like telephone wirings, which I have done it throughout the years, and I have learned the technology to keep the cost very low. Okay. Then wireless, sure, inside the home is a very good solution. Wireless makes more sense inside the home than inside the office. Because inside the home, cost is more important, and cost of wiring is more important, and cost of bringing labor. And actually bringing the labor, people are reluctant to bring labor inside their home because the management is time consuming, and also people don't like. That's the privacy. But in the offices, it's different. So wireless is becoming more popular inside the home for the distribution. Also inside the home, we have cable TV for the video today. And people wanted to use it for data, but it's not useful because you don't have many cable connections inside the home. You have many voice connections. Okay? I mean, telephone, almost every room you have a telephone jack. So is there anything else that I can use inside the home for distribution? Of course, that's power line. Because inside every room I have what? Several plugs. So people try to use that too. Okay, so these are mediums for distribution inside the home. So now the industry evolves around these things, around these mediums, and how to generate a logical business entity to develop a product, not an innovative idea, really. Okay, so business plan should work first. That's the most important thing, not the technology. Okay, now classification. Now, I mean, when you get these networks, I told you, I took the entire networks and I divided in what? 3 different segments. One was like core network, which is backbone. I called it backbone. One was the access, which comes from the backbone to home or office. And one was distribution inside the office or home. Now, we can classify these things also in different ways. Okay. One is we can classify them by access. For example, we can say a bunch of these are tethered, a bunch are untethered. Well, a bunch are wireless, bunch are wired, if you want to call it. Okay? This is one classification that people often use. Okay? The other one is classification by connection, by the type of connection. We have talked about those so far, like connection-based. Voice application is connection-based. Means that I dial up, I get a connection, and then I hang up. Okay? It doesn't need to be voice. It could be data, like TCP. But anyway, it's a connection-based type of like classification. The other one is connection-less, which is like I send everything as they come, packet by packet, not as a group. And then broadcast or streaming, like video, audio streaming, whatever. So this is another way that people try to classify by connection. First by access, then by connection. Then sometimes they divide them by industry, like telecommunication industry, computer communication industry, consumer product industry. That's possible. Telecommunication industry is voice-oriented. Computer communication industry is data-oriented. Consumer product industry is like really, if you want to relate it to network, ad hoc networks. Like you have a bunch of products, they want to talk with one another. That's something. Another way to divide these telecommunication, in fact, system is by the area. By area is very popular. People divide telecommunication networks in wide area networks, which is like international coverage. CETA is the network for airline reservation. That's a private network which works everywhere. You go to Tokyo, you come to Boston, you go to wherever. It works. So it's an international. Then we call those things wide area network. Then they have metropolitan area networks, which are in a metropolitan area within few kilometers. Okay. Standards like 802.6, 802.16 are related to the MANs, for example, metropolitan area networks. Then I have LANs, local area networks. Local area networks are covering, according to 802, a standard up to 100 meters. Okay, today. Originally, when they started, they were covering up to like 2.5 kilometers. But this 100 meter is from one connection. Okay, so you can have a bigger coverage. Examples of the local area networks: Ethernet, which is 802.3, 802.11, which is wireless LANs. Then, more recently, they have home area networks, which are within like tens of meters, which is a LAN for the home. Okay. Example of that, HPNA, I told you, home RF, power lines, networks, and again 802.11. Okay. That's for home area networks. Then they have another layer, which they call it personal area networks, which are much more recent, within 10 meters. This is something that you want to have your personal equipment to connect. You have your mouse, you have your keyboard, you have your computer, you have notepad, your cell phone, and they want to talk with one another. That thing, they call it personal area networks. Okay. But these things are overlapping. I mean, the definition. I mean, PANs and LANs and HANs, they overlap a lot. Okay. And MANs. All of them, they overlap. Okay. But people use this type of classification in the industry today. Okay. There are two parts for our course, really. We have PANs and LANs, which is one part, and the other one is MANs and WANs, if you want to call it. We can divide them. WANs are the backbones. MAN is access to the backbone, okay, if you want to call it, according to those three sectors, if you want to call. And then there are some financial consideration to separate these two groups. MANs and WANs usually are very expensive. So a major company owns them and they provide you as a service. They have monthly service. It's a very stable industry. Anything which has monthly service is a stable industry. It's very good. But it needs huge investment. Okay. Then PANs and LANs are local area networks, and they are owned by either the company or by the person. Okay. Now, another difference between these two, MANs and LANs, if you want, or WANs and LANs, PANs, LANs, and MANs and WANs, if you want to call it, wide area and local area networks. In terms of operation, this is very important. If you subscribe to a WAN, you don't need a manager. They provide the management. If you own the system, which is like your LAN or PAN, you have to manage it yourself. Okay, so it's more difficult to run it. So you need many people, like managers around in WPI, to come and fix your computers. Okay, you have to pay for those things. You have to organize that thing to run it. But when you subscribe to the telephone, you don't need any manager. You subscribe to the WAN. Okay, that's major difference. And since they have service charges in WANs, they are steady and major industries. The other one, which is local, is temporal. Goes up and down with the economy. Okay. And complexity and diversity of the technology. Wide area networks, they have larger geographical coverage, and per user they provide a smaller data rates because they have to accommodate many, many users. But their data rate that they support is much higher. But the portion per user is lower. When you come to local area networks, you can provide cheaper, higher data rates. Okay? So these are the way that you can classify these things. The last standard, the last thing that I have in here is name of a bunch of standard activities which are working on telecommunications. The most important one, IEEE, which works on local area networks. Like 70% of our course, maybe even more, is about local area networks. Okay? Most of the popular standards are IEEE. Then is ANSI, which is American National Standard Institute, IEC, ISO, IETF, ITU. These are all international. So we have a bunch of organizations like IEEE, which are like scientific organization. We have a bunch of things like ANSI, scientific and local. ANSI, which is like national, and we have some like ITU, which are international. Okay? So the way that a standard evolves, a standard starts from a technical committee, for example, in IEEE, or in like ATM Forum, for example, or in Cable Lab, for example. Okay? These are all technical groups. They develop the standard, then they go to ANSI to make it a national standard. Equivalent to ANSI in Europe is ECE. Where is ECE? This is ECE. Okay? They go to ECE or they go to ANSI, it becomes a continental. And then they go to ITU to become an international standard. Okay? As a result, we have a bunch of standard subcommittees. But sometimes ITU itself designs a standard. ANSI itself designs a standard. Okay? So that's the format of the thing. Then they have like technical groups under them. So standards are evolving all over the place, either by technical groups which are outside of national and international communities, or inside the international or national communities, there's a group which does that. And we will see the examples of these things in the lectures to follow. Thank you so much.